In Switzerland, engineers have begun implementing one of history's most daring technical projects, the construction of an enormous tunnel no one has dared to attempt before, approximately 57 kilometers long and 2,400 meters deep. The world's longest tunnel will pass through the heart of the Swiss Alps. This dangerous plan aims to redirect Europe's traffic and goods routes not over the Alps, but through tunnel construction, a long and difficult process. Engineers must drill through the hardest rock on Earth. To do this, they will need the largest drilling machines on the planet. These machines are taller than 3 stories high, longer than 4 football fields, and work 24 hours a day, taking 6 years to complete the task. Can this project be completed as planned? What technical challenges did the engineers face while constructing the tunnel? Let's explore together in this video. This tunnel construction project cost a total of $10.3 billion and includes 2 railway tunnels crossing the Alps, each 57 kilometers long. It is the longest tunnel in the world, longer than Japan's Tecook tunnel. During the construction of this project, the engineers had to endure immense pressure from the Swiss government. Firstly, they had to ensure that the tunnel could last at least 100 years. This meant that all materials used in the tunnel had to undergo the strictest inspections. Not only materials, but the time was also very tight. If for some reason, the project From the scale of the project alone, workers will have to excavate 24 million tons of rock from the Alps, enough to fill 16 football fields. The construction conditions are very harsh because the tunnel is located deep underground, and internal temperatures may reach nearly 50 degrees Celsius. Workers must risk inhaling dust and oxygen deficiency while working in the dark, putting their lives in danger every day. But this is not the entirety of the excavation. The tunnel ultimately represents a battle between humans and the Earth, facing various threats. To minimize risks, geologists take samples deep within the mountains before starting to determine the types of rocks workers might encounter while excavating the tunnel, in order to devise the safest and most effective methods. If it is a hard rock area, they can use EBM machinery to excavate the tunnel. But if it is soft rock or unstable areas, they must use another method, which is pre-drilling for blasting. In areas with water-bearing rock, due to issues with internal pressure, an effective solution has not yet been found, which could exponentially increase the level of danger. The safe tunnel route had been determined, and the next step is to design how the tunnel should be. A single large tunnel with 2 tracks inside would be the most economical solution. However, this design has a serious flaw. If a train derails inside the tunnel, it could crash into an oncoming train or cause a blockage of the tunnel. A safer alternative would be to use a single tube system, similar to the one used in the Channel Tunnel between England and France. This tunnel consists of 2 tracks, one for each direction, and a smaller central tunnel for emergencies. Engineers need to carefully consider the pros and cons of each design option. Clearly, the single tube system is too dangerous, while the 3 tube system is too expensive. Therefore, they proposed an alternative design, with separate tunnels extending north and south, which would reduce the risk of direct collisions to improve safety. They also added separated passages every 300 meters, allowing rescue teams to move between the 2 tunnels, and cut points along the line will allow trains to switch from one tunnel to another in case of emergencies. The designers also added another important feature, a series of small passages connecting to the opposite escape route, and each tunnel will have 2 first aid stations. In theory, this could be the safest tunnel through a mountain designed so far, but until it is tested, no one can be certain if everything is ready. Next, let's look at the work of starting to construct the tunnel. First, regarding the construction plan, the engineers proposed using 2 excavators to dig from both ends of the tunnel. But how to ensure they meet in the middle of the tunnel? To guarantee the most accurate mapping information, engineers used the Global Positioning System GPS. GPS receivers were placed at the entrances on the north and south ends of the tunnel, as well as at 3 intermediate points along the planned tunnel route. Each excavator is over 400 meters long, weighs 2,700 tons, and is disassembled into 500,000 parts for transport from Italy to the site. It takes workers several months to reassemble. The most difficult part is the 2 cutter heads of the tunneling machines. The cutter head has a diameter of 10.7 meters and weighs 187 tons. It needs to be moved from a lying position to an upright position and installed onto the main body of the tunnel boring machine. After 4 hours of hard work, the cutter head was finally placed accurately. When everything was ready, the machine could start running. This machine has 32 hydraulic pistons, providing 5,700 horsepower to push the blades forward, reaching up to 26 tons per day. It can dig 30 meters forward while the excavator is moving forward, continuously transporting the remaining parts to the site. Every 2 meters, they will stop and use robotic arms to install the remaining components. Each component has rubber rings to form a seal, preventing water and toxic gases. To improve tunnel stability, they pump a fast-setting concrete to fill the gaps between the rock walls and the tunnel. The excavator can dig 2,000 tons of rock and soil each day, which is then transported out by trucks for reuse. After the excavation is completed, the inside of the tunnel is lined with a concrete layer and prefabricated concrete components. This requires a large amount of concrete, nearly 40 tons. The excavated rock can be reused for concrete production. This helps reduce project costs and protect natural resources. Some tunnel areas cannot use TBM machines because these machines can only excavate in straight lines, passing through hard rock layers. For weak and unstable places, using excavators may lead to landslide risks. Therefore, the tunnel is excavated using the traditional method of drilling and blasting. The first step is for workers to align the drill bits with lasers, and then a computer calculates the blast model for maximum efficiency. The drilling process then begins. A total of 80 holes are drilled, each 5 meters deep into the rock wall. 2 different chemicals are injected into the holes by workers in precise measurements. These chemicals are harmless on their own, but when mixed properly, they become a high explosive. On October 15, 2010, the last piece of rock of the tunnel was penetrated, setting a new world record. After 11 years of construction, the widest railway tunnel in the world was finally built successfully. In this episode, that's all for today. At the end of the video, don't forget to like, share, and follow, so more people can know about us. See you in the next video.